Conditional probability and independent events. Consider two events A and B. The conditional probability is defined as P. A, you can put a bar, vertical bar, B, which is probability A intersection B over probability B. And we read this one as probability of A given B. That means we need to find the probability of the event A when event B is known. So that is basically the definition of conditional probability. Now we'll see one example and then we'll go to the next, which is independent events concept. We are given probability A intersection B is 0.25, probability B is 0.75. We need to find probability A given B. We can just use the formula we have and see what is our answer. So using the definition, probability A given B is probability A intersection B over probability B. So we have A intersection B is 0.25 and probability of B is 0.75. So when you simplify, you get 1/3. So that is the probability. We are now given a Venn diagram with two events A and B. So in this way, so you can see here probability A will be 0.12 plus 0.13 and probability B will be 0.13 plus 1.17 and the intersection is 0.13. Now we will find more information from this. So let me write what we have in this diagram. So we have collected all the information. Probability A is 0.25 and probability B is coming 0.13 plus 0.17, which is 0.30. And then the intersection of these two events, probability A intersection B is 0.13. So now we can easily find probability A given B and probability B given A. So let's try both of this. So as you see, probability A given B is probability A intersection B over probability B. So A intersection B is 0.13 and probability B is 0.30. So we can write the simplified answer now. So we get 13 over 30. So that's the probability of A given B. Now let's do it other way. So when I'm looking for probability B given A, so now I will have probability B intersection A or A intersection B, they're same, divided by probability A. So now you plug the answers and simplify it. So I'm done. The probability B given A is 13 over 25. Now we'll see what is meant by independent events. So the next definition is two events A and B are independent if probability A intersection B is same as probability A times probability B. So that means A doesn't depend on B. If you just see from the conditional probability here, if you do the cross multiplication, you get probability A intersection B is same as probability A given B times probability B. So if A doesn't depend on B, then probability A given B will be simply probability of A. So in that case, you have this situation. So I'll write by hand and show you what happens. So from this formula here, if I do the cross multiplication, so I'm getting probability A intersection B is same as probability B times probability A given B. So when you say that probability A given B is simply probability A, that means A doesn't depend on B. So in that case, you are getting probability B times probability A, and in that case, the events are called independent. So the example we have right now here, if I'm just taking probability A, which is 0.25, probability B is 0.30, and intersection is 0.13, so it doesn't match, like this condition is not fulfilled. So in this case, these events are not independent. So I'll take another example where you can see independent events. We can look at the example now. The Venn diagram shows the intersection is 0.12, and then the probability of A will be 0.28 plus 0.12, which is 0.4, and probability B is 0.12 plus 0.18, which is 0.3. Now if we just see the multiplication of probability A with probability B, so 0.4 times 0.3 is 0.12, and which is exactly probability of A intersection B. So in this case, the events are independent, and we are done. All right, thank you. So in the next lecture, I will talk about conditional probability and Bayes theorem.